Hi everyone, are you able to hear me and see the screen clearly? Please respond using the chat window. And if you have a question, please ask using the Q&A window. There are two windows. One is for Q&A and other is for chat. All right. So you can respond using the chat window and ask your question using the Q&A window. All right. So wonderful to have audience from all across the globe. Today, we are going to talk about the deep learning. We're basically going to talk about the introduction to deep learning. This is not going to be a very technical session. It's going to be fairly non-technical and generic session so that everybody gets the hang of what is machine learning, what is deep learning, and what are the various challenges and what are the various tools to use. So we will be talking about that part, though we will be briefly understanding what does it mean by neural networks and so on. All right, so great to have all of you in the session. Today we are definitely going to be more than 200 people in this session, and so ask your questions using Q&A window, and be ready that I would be answering lots of questions in this session. And try your best to ask your questions using non-chat language, because I'm not very great at chat language. And feel free to ask your questions using Q&A window. All right. Great. All right, so welcome to the first session of deep learning. All right, those who are looking for the presentation, let me just give you the link to presentation. All right, so, okay. Or I'll give you later. You'll get a PDF of this presentation. All right, so wonderful to have all of you in the session. Now, moving ahead, a brief introduction of CloudX Lab. We are trying to make learning fun and for life by the way of videos, quizzes, hands-on projects, and case studies. And all of these are based on real-life use cases. The focus at CloudX Lab is learn by doing. This is the first and the only session which is theoretical, or you can say partly theoretical. Remaining sessions are very hands-on, and also we have built a assessment tool whereby you will get a problem statement, you have to do the hands-on on the labs, and it checks your work in the lab and gives you the points and make sure that you have done it in the right way. All right, so we have built these tools on top of the existing tools such as Jupyter and other Linux and other systems, so as to make the learning like a game, that you do something, you get a feedback, you do something, you get points, and you keep on moving ahead in the career. All right, here's an example of the automated hands-on assessment that is asking you to click on I am done with, and so on. This is another one whereby it's asking you to define a variable access 10. Once you have defined something on the notebook, as you can see on the right-hand side, that access 10, and then it checks your work and gives a message saying, good job. All right. All right, so okay, so this is the first session of our bigger course called Deep Learning with TensorFlow. All right. This course is a very hands-on and deep dive into TensorFlow and deep learning. And from the second session onwards, we are going to be working on the TensorFlow. So today we are going to do the introduction to deep learning, and in the next session, we are going to be up and running with TensorFlow. Of course, these are not session-wise. There could be two sessions of 3 hours each that would go into understanding TensorFlow, and we'll also be learning PyTorch this time. And then we'll be doing the introduction to artificial neural networks. Then we will be learning deep neural networks, and then convolutional neural networks, recurrent neural networks, and autoencoders. Here we'll be also learning how does Google Translate kind of systems work. Here we'll be learning how does the image recognition and complex systems work. And here we will be learning how the stock trading, if you have to automate the stock trading, how would you build that using neural networks? And we'll build a basic system to do the predictions given certain predefined data. And here we'll be learning how to make the computer learn to play the games. And afterwards, there'll be projects and so on. So this is the full course. It might go for 2 months and or maybe more. All right. So all right. A brief about me. I'm Sandeep Giri, and I graduated from IIT Roorkee in 2002, really long back. And I have mostly worked on large-scale computing and machine learning and big data. I started my career at DE Shaw. How many of you know DE Shaw? You can use chat window. All right. So DE Shaw is a very interesting company, and we did lots of data churning in terabytes when the world was handling the gigabytes data. It's a company where Jeff Bezos, the Amazon founder, also worked. That was his first company. And DE Shaw was the first company where I got the exposure to humongous data and large-scale computing. We had 10,000 node cluster long back in 2002. Afterwards, I worked with InMobi. In the meantime, I founded a company called T-Bits Global, where we build the software to build the power plants, the thermal power plants specifically. And then at InMobi, what I did was I built the recommendation engine to give the recommendations instead of showing the ads. That was one of the projects which involved around 200 terabyte data, and it was a real learning. Afterwards, I worked with Amazon. At Amazon, the detail page that you see on the mobile, that was what we built for the mobile. And when you basically the page where you do the buy now, that was the page we owned. And at Amazon, the other thing that I did was optimizing the image that is shown as a product image on the detail page. That was something we did in a very in a distributed environment. So at heart, I'm software engineer. At heart, I'm software engineer, but I enjoy explaining or teaching everyone, and that's why we have started CloudX Lab. All right. So this is about me. All right. So there are a few questions I would like to answer now before going ahead. All right. Okay, so let me answer. There are four open questions, and let me see if I can answer those questions before moving ahead. A question is from Mercy. How does deep learning work with Python? So basically, in Python, there are many libraries like PyTorch, like TensorFlow, using which you can call those libraries using Python and get your work done. All right. Okay. A question from Arun that I think the refresh rate is very slow. I now see Jupyter Notebook slide. Oh, is it so? Is the refresh rate slow for everyone? All right. All right. So a question from Yang is what's the difference between deep learning and machine learning? I'm going to talk about it very soon. All right. Great, great. Maybe for some of the users, it looks really slow. All right, so moving ahead. All right, great. So let's move ahead, and I'll like to answer your questions probably once I cover few of the topics, so that we are in the context, and then probably my answers will make more sense to you. All right, so let's get started. So at CloudX Lab, we have a free lab in the sense that you can sign up for free lab. The free lab is free for 7 days. And the only thing is that you'll have to do a KYC, we call it Know Your Customer, which is kind of mandatory. For that, you might have to make $1 payment, and that will be refunded to you probably in a couple of hours. And in case you are coming from education institutions having your email ID ending with .en, .ac, your country, or your email ID having .edu in the last, in that case, you will get the KYC will be done very quickly. KYC as in know your customer, and the lab will be for 1 month for you. All right, so you can just sign up. You can go to CloudX Lab. You can click on Start Free Lab, and then you can go for the enrollment. All right. So a question from Yang is that I cannot log into Jupyter. All right, we will see that later. Even if you have not signed up, you can sign up during the break. Now, moving ahead. All right, so let's get started with the understanding of deep learning, machine learning, and the other parts. All right, so what does it mean by deep learning or machine learning? We use the word machine learning and deep learning and AI interchangeably. I'm going to talk about it in details. All right, so first of all, let's get the hang of what does it mean by machine learning or deep learning. Okay, so now here's a question to all of you. How much time did it take you to learn Mario? Have you played Mario? You can answer using chat window. How much time did it take you to learn and win the princess? All right. Now, do you think that program can do the same thing? I'm going to go ahead and show you how it looks like. So Here, what we're going to show you, what I'm going to show you is that the program learns to play Mario, observes the game and the key presses, and maximize the score. It was done long back by Tom, long ago. And, and what happens here is basically the program is hooked to the emulator. These days you can create, in case you want to play Mario, you can launch the Mario game inside your computer using emulator, SNES emulator. And there you can play Mario. Same thing is done in this setup, whereby the game is being played in the emulator, and the software is talking to the emulator and interacting with the game. So essentially, the software, the machine learning bot, you can say, or you can say algorithm, is interacting with the environment just like we do. It's pressing the keys, observing the screen. And the screen is essentially in the memory. All right. So this is the day zero when the program is playing really random keys. It's not going anywhere. It dies off the old days. This is the day zero. Okay. Now, after a few weeks, it's playing really better. It's playing a little better. You can see it's able to move ahead. No idea why it's looking backwards, but it's playing really. It's playing like a toddler, like somebody who is beginning. After a couple of more weeks, it's able to do really good job. You can see that. So it learned it by itself. It learned it by itself playing Mario. It kept on pressing the keys and observing whether the score is going up or not, observing the screen and observing the key presses. So it figured out the correlation between how to go ahead. So you can see that it was able to do really good job. Now it's not having a problem at all. Right? Now, a few more weeks and the program is an expert at playing Mario. So you're going to see something amazing. You're going to see something amazing. See, what was that? So the Goomba is falling on it and it starts slightly moving downwards and gets the point. So it figured out a bug in the Mario by itself, that we never knew that such bug exists in Mario. You're going to see another bug being exploited by the program. You can see that. See, it was about to fall and it came up. No idea how does he do that. Now, it was hooked to another game, and when it was not able to win the game, it kept on pausing the game. Just like in childhood, when your siblings or your cousins could not win the game against you, they will spoil the game and run away. In the same way, the program kept on pausing the game when it could not win it. So that sounds like intelligence, the generalized intelligence, right? So the purpose of this showing this game was that nobody actually taught the program how to play Mario. Nobody actually taught the program how to play Mario. Nobody taught it that there's something called gravity. Nobody taught it that there's something called objects. There are something called edges. There are something called collisions. Nobody taught it. Nobody explained or nobody coded that there is something called physics and there's something called collisions. The program figured out by itself. And since it understood, since the way the program is looking at the Mario world is far different than us, it was able to exploit the bugs in the game. All right, so this was an example to show you what it means by machine learning, what it means by deep learning. And All right. So basically now, basically the program learned to play Mario and other games without any programming, without we needing to do the programming. The only programming was needed in terms of hooking the program to the Mario and launching it in a simulator and so on, right? So we will be doing a similar project towards the last session in this course, whereby our bot will learn to balance the 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 the, the ball on a card. There are many such games we will be playing, and we will be training our bot, our program, and so on. So now, question to all of you is that to make this program, whatever learned Mario, to make this program learn any other game, such as Pac-Man, do we need to write new rules as per the game, or just hook it to the new game and let it play for a while? Do we need to write the entire logic that how to play that game, or do we just need to hook it and let it play? You can answer one or two using the chat window. That's right. Just let it play for a while and hook it to the new game. Okay, so that's machine learning. All right, so imagine doing the same thing for the life, gathering data and automatically solving problems. If you look at our life, we basically are interacting with the environment and doing things which are good for our health and good for our family and so on, right? So we have an objective function, right? And similarly, we have an objective function in case of Mario, right? So here, if you think about it, if we gathered good enough data, we are anyway doing it, we'll be able to solve large-scale problems, and such as curing the disease, which are like such as cancer, curing the disease, avoiding the collisions, avoiding the conflicts, and so on, right? Now today, as we move ahead, also I'll be using the deep learning and machine learning interchangeably, because deep learning is basically part of machine learning, and the machine learning is a general term to say that let computers learn by itself. Making the machine learn to do things is called machine learning. And deep learning is part of machine learning, whereby we solve really complex problems, such as the self-driving car on the roads is an example whereby we have to, whereby we build a car, or the car learns to drive by itself, observing traffic and so on. Today, there is a tsunami of applications because of the deep learning, which is a branch of machine learning, specializing in solving really hard problems, right? Netflix movie recommendation. This is something that we don't know, and recommendations, the one that you see at Amazon, the one that you see at Netflix, they are also the use cases of machine learning or deep learning. All right, so Google also uses the machine learning or deep learning in order to give you the results accurately. Okay, the speech recognition, for example, like the way earlier what we did was we tried to write the code, try to detect the patterns, whether when we say, okay, Google, Alexa, or Yang, or Lalit, or Sunny, when we say these words, we wrote the rules saying that if the word looks like this, it should be this. Now that was not enough. That was not enough because that was almost an impossible task. Therefore, in past, in past, the speech recognition wasn't as great. And today, just like Mario, just like the way our program learned Mario, in the same way, the, the speech recognition systems are trained that this sound is okay, Google. This sound is okay. This sound is Google. This sound is deep. This sound is learning. This sound is tsunami. This sound is speech, and so on and so forth. So, giving a huge database of sounds, giving a huge database of sounds, the speech recognition systems or the machine learning systems were trained. And once they're trained, just like playing Mario game, they are able to convert a sound into the text, meaning when we say something, it's able to recognize. So speech recognition systems have also changed drastically after this deep learning, after this machine learning or deep learning has become really successful, specifically deep learning, because machine learning had been there for very long. Machine learning is the uh, classic ways, and there are improvements into machine learning that come under the deep learning. All right. So question is, what do we generally need in machine learning? We need two things. All right. So in order to successfully build an intelligence like the way we played Mario, whereby we let it play for a while and let it figure out the game by itself, which one is making score, which one is not giving you score. Now, the idea is that we gather the data. In case of Mario, the life was easier because we were able to gather, generate data by playing the game over and over again. That was basically the data that we were generating when we were playing games. The which frame gives, or like which arrow, which key presses on which screen is giving what result is the data in case of Mario. Similarly, if you want to solve any problem in case using machine learning or deep learning, there are two things we need. One is data, other is intelligence, right? Intelligence means the algorithms and so on. All right. So before we move further, let me take questions. I have not taken the question for some time. Let me try to answer your questions. A question from our Dover is that, don't we need to specify the rules? We don't need to we don't need to write exactly the steps to solve a problem. Instead, we need to specify the objective function, okay? All right. A question from Balagvasi is that, does this imply that no manual input is required to train the deep learning algorithms? So in case of deep learning algorithms, we'll be feeding mostly the data. We don't really tell the program exact rules of the game. We can't, all right? We can't really tell the steps that, like in case of Mario, we can't, let's say if we are using deep learning for solving the Mario game, we really cannot tell the program that there is gravity, there is collisions, and these are called edges, and this is called dying, and so on. All we do is figure out an objective function, right? Against which the program has to keep on trying over and over again to achieve that objective function, and so on. All right. the input data along with the objective function. Okay, a question from Lalit is, can we do the same thing using Anaconda? Of course, you can do the same thing using Anaconda, but the evaluation, the question is related to, in the CloudX Lab, we are providing the whole environment where you can do the hands-on and so on. So question is, can we do the same thing using Anaconda? Yes, you can do that. For that, you'll have to install Anaconda, and there you will get, there you'll have to also, what do you say, install all the libraries required. We have done the same thing in the CloudX Lab. The difference is that we have also provided the lab, we've also provided the lab with the data set along with the auto assessment. So our system can only check if you're working on the CloudX Lab. All right. So if you can share the PDF in advance, it will be easy to take notes. Okay. All right. Don't worry. You can just take a screenshot, and this video is going to be shared with all of you. And okay. So this video that we're using right now, we are recording right now, is going to be shared with all of you. A question is, does Jupyter Notebook crash when using Windows Edge? I'm not sure. I've not used Windows Edge. All right. It doesn't actually. I've used on other Windows. It does work, but I'm not sure about Windows Edge. A question is, what is the intelligence on this screen? So we are saying that we need two parts to solve a problem. One is the data as in the input and expected output and so on. And the intelligence, meaning the algorithms and the CPU and so on, right? The computer, the algorithms and so on. So those are the two things that we're talking about. A question from Y is that, how does Google translates the sound into text? It has been mostly trained on a lot of data in order to convert the sound into the words or text. A question is this Mario example of unsupervised learning? No, it's called reinforcement learning. We'll be going into classification very soon. All right. A question is, do we need to provide data for all the scenarios or basic ones, and will it handle the complex ones? Okay, so good question. We generally don't have to provide for all scenarios, right? If it's just recalling that for this scenario I have to do this, that's not really machine learning. We call that recall-based systems, or you can say, I'm going to go into more details at a later point of time. All right, just be with me. It's a very good question, and I would love to answer it. Okay, great. All right. Question from Caro is that, how does machine know that the objective is to get more points? That's the part that we need to define. That's the work of something that's the work we need to do. Okay, so that's the part which we need to code. In case of Mario, that the machine needs to get more points was being retrieved from the memory, because there is a variable on the screen which is in the memory, whereby in the memory of the computer, whereby it's storing the points. So we made basically, in the case of Mario, we made the program look at that memory and figure out ways to maximize that score. All right, that part we need to define. Great question. So a question from M. Ramchandra is that, does this session include PyTesseract library? Not much. We are going to mostly talk about the the ways of deep learning. We are going to probably take one session on the computer vision. Probably we can talk about PyTest and OpenCV at that point of time. All right, great. So there are very good questions, and all right, can I answer your question probably towards the end, because your questions are something that I'm going to answer here. Okay, I'm going to answer here as we move ahead. And if you get answered, you can probably take off the question. Otherwise, I'll answer your question probably in after say 15-20 more minutes. All right, your questions are something that I'm going to anyway answer. All right, wonderful, wonderful. So let's move ahead, and it's time to move ahead. All right, so basically, when we are solving any problem with machine learning, there are two big parts to the puzzle. One is data, and the other is the intelligence, right? Given the data, build the intelligence. Those are the two parts. Now, with respect to data, we need to do three things generally: collect, clean, and process, right? And basically, if you take a look at the two steps, cleaning and processing, is not really too much of difference. They both are overlapping with each other. Now, to collect the data, we need the IoT devices, we need sensors, we need probably our scripts which can crawl the data from internet and get more and more data, right? So to collect the data, one is we need the IoT devices, right? And the other is connectivity, of course. And both of these things have become really, really prevalent. And that's why today we are talking about machine learning. Machine learning has always been there, just that today, as of today, the environment is far more conducive. We have the IoT devices, we have great bandwidth, we have we have great computers and so on, right? So now, so collecting the humongous amount of data and cleaning it using the many computers that are involved. Okay, so let me go back once more. So essentially what I'm saying is that we require data and intelligence, and for data we need to do collect, clean, and process. For collecting, we could use the classic programs which basically crawl the website, download the data, or we could use the IoT devices. Now, when we come to cleaning, when the data grows bigger and bigger, right? Bigger data is better, but when the data is bigger, we can't really get the work done using a single computer, the standard one. So what we do is either we go for many computers or we go for many cores in your computers, right? So to be able to clean the data on a larger scale, we require parallel computing. Parallel computing means that utilizing many CPUs, many processors in parallel, many computers in parallel, to solve a problem. First of all, first part of the parallel computing is distributed computing, whereby we connect the computers in a network so that they can interact with each other to achieve a common goal. The second way of parallel computing is by the way of having many processors in your computer. Like your computer might be having 4 cores, 8 cores, or your computer might be having a GPU. We call it GPGPU, General Purpose Graphics Processing Unit, meaning we can have many processors interacting with the running in your computer so that they can do far more computation on your parallelly. Okay, so this is the second form of the parallel computing, whereby you have many processors or the core that perform tasks and interact using the memory or a bus. So now the GPGPUs have become really powerful today, and because that's another reason. So one is IoT devices have become very uh, available. The other is the connectivity has become very much everywhere. And second, and with respect to cleaning the data, we generally require parallel computing. And first form of parallel computing is distributed computing. This is what Hadoop and big data and all of those environments provide you, that you can utilize many computers to store data and to process data. All right. And the other way of doing the computing is the GPGPU computing. And so when we talk about GPGPU, basically we're talking about many processors kept in the same place and doing memory. Okay, so question is, how is GPGPU different from TPU? Basically, there's a slight difference in the architecture. Otherwise, the purpose is same, using many processors to interact with the memory. Okay, and those who are interested to know, I'll give you a very quick brief on when to use what. So multi-core computers you already have, like dual core, quad core, that's multi-core systems. Now, further, when we compress more and more processors into a single computer, that's basically, we used to call it graphics card when we used to play games. And now the same thing has become very useful in doing the machine learning, because it can do lots of processing in. Now, the third way is doing the distributed computing, whereby you have many computers available. So those are the three things. Now, when you have to handle huge data, in that case, distributed computing is the only way to go, because you need many hard disks, many disks to read parallelly, right? When you need really fast communications between the system, between the CPUs, in that case, you go either with multi-core or GPU. If you're really building a deep learning system which requires a lot of maths, a lot of mathematical computations or graphical computations, in that case, you go with the GPU. In short, we call it GPU. All right. Now, there are many tools available today. If you are utilizing multi-core, probably every system can utilize multi-core. And if you're using GPU, you will have to use the systems like Keras, TensorFlow, Caffe, PyTorch, and Spark. Spark is experimentation, it's not there yet. For distributed, you will have to either go with Hadoop or Spark. All right, so that was a very brief one. Even if you did not get it, don't worry. It's completely okay not to understand every part of it. Just know that in order to process data, we would require many processors. All right. Now, let me take your questions at this point of time. All right, let me take a question at this point in time. Okay. All right, this I have answered. So TPU is essentially a slightly different architecture than GPU, but it is purpose is the same. Okay. A question from Lalit is that, as I understand, ML is giving some conclusions, predictions only. Can we give 100% surety? Right? That's a very hard question to answer. Okay, I'll explain to you why. Question is, how do you trust your pet? Or how do you trust anybody for that matter, right? So question is, how can I be sure that the results are right? Right? So what you do is you So most of the machine learning is all about predictions, correct? The most of the machine learning is all about predictions. And that too, we also do the same thing when we are playing tennis, right? When we are playing tennis, what is it that you're doing? We are predicting how, at what angle should we hit the ball so that we don't miss it and it goes in the it stays within the boundaries, right? Similarly, whatever we do, we are essentially at every point of time we are predicting. And when you think about even, let's say, creation, when a human creates something, when we have let's say a musician creating a new music, that's also a form of prediction, right? Creating a music, knowing that, understanding subconsciously that what music will sound better to my ears is basically a form of prediction. So intelligence, the way we look at it, is actually mostly about predictions, right? That's mostly about predictions. Now, same thing is done by the machine learning, deep learning, being able to predict given the past history of the data, right? Now, question is, how can we trust it? The way we trust anybody is that we ask them things that we already know, and we can compare their answers, right? In the same way, in machine learning, the concept is that we keep the known instances separate. We call that test data. So 20% of the data for which we know the answers, we keep them separate. And then we ask the machine to do the prediction and then compare. And the way we compare depends upon what we are looking for. Are we looking for a machine not to make even a single mistake? Are we looking for a machine to be okay at quick prediction and so on? So the way we check somebody uh, is up to us, and or when we are asking machine to do the predictions, we will compare the results against our predefined data sets, and based on the severity of our work, we will we will consider whether to whether to go ahead or not go ahead. All right, so that's a quick answer, and I've answered this on forum also. I'll send you the link. All right. Okay. All right. So moving ahead, there are, let me try to answer a few questions. Question is, can we use GPGPU on distributed network to handle huge data? Um, Good question. Good question. Can we utilize GPU? Can we utilize, the question is, can we combine these two? Have distributed as well as GPU and do that? Yes, we can do that. The only challenge is that not every logic can be broken down to be done parallelly on the network, but programs like TensorFlow, or you can say libraries or frameworks like TensorFlow, they are able to do the GPU on distributed. All right, so it's very much possible to do that. Great question. So question is, okay, All right. Our question point is not trying to predict it's all pattern recognition. Yes. So the purpose of pattern recognition is doing something. Okay. So one is part of the puzzle is pattern recognition, and other is you recognizing pattern and doing something. That's also one form of the machine learning. Okay. All right. I think these questions, the other questions that I'm skipping for now, I'm going to talk about these further. A question from Tani is that for data processing slide, what is huge data here? What type of size are we talking about? All right. So here, all right. So in very simple words, when we are trying to process huge data, right? So in general, the bigger the data, the better it is. But the challenge is how do we process it, right? As the data grows bigger, the chances of getting great results is better, right? And getting the great results is better, and therefore we would like to have as bigger data as possible. But the challenge with that is the bigger data you have, you can't really process huge, humongous data on a single machine, right? If you have like a few terabytes of data, it'll take like a couple of days to even read and write the same data back, and therefore we require the distributed computing. So again, there is no strict definition of big data or huge data. We generally see that whether we are able to do it using one computer or not, and then we move ahead, or we do the back of the envelope calculation based on at what pace can we read the data from the disk, or what kind of disk are we using? Are we using the faster ones, like such as solid state drives, or are we using the slower ones like hard disk drive? Okay, so based on our decisions with respect to using frameworks, what framework to use, whether to go with distributed frameworks or go with only one computer, is a function of what kind of data do we have, as well as what kind of computing that we need, and so on. All right. Our question is how big data we need to train deep learning models. What if we have few data? What are the tactics to increase data? For instance, we have chatbots with few labeled data. All right. So okay, that's a hard question. So question is that we talked about data so far, that there is huge data needed and so on. What if we don't have that big data? How much data is needed? One of the challenges with the deep learning is that we need a lot of data, right? Because we are letting the system figure out things by itself. We don't want to give it the rules. We want the computer to figure out the rules, right? Therefore, having huge data is required for most of the deep learning. Now, how huge? There is no set definition as such, but if you have like many columns, then you'll require huge data. Okay. As in, if you have many columns, you'll require many rows. I'll talk about that probably at later point of time. Now, what are the tactics to increase the data? There are many tactics. One of them is called data augmentation. The other one is utilizing somebody else's pre-trained models. One thing that has come into play is that we can download the data from we can basically learn from other people's learning. Okay, so we can use data augmentation. We can use the pre-training, or we call that transfer learning. And we can also utilize the data gathering tactics by crawling the data, by picking up similar data, if not the data for the same purpose. All right. So good question. Good question. So like for example, if we are building a chatbot, right? If we are, let's say, building a chatbot and we want the chatbot to learn the language, but we don't have too much of data, right? So what we can do about that? What we can do about that is we can look for public forums. First, we could look at, say, Wikipedia. We know Wikipedia has a lot of text, and from there, the way human learned the definition of words, the bot can also learn the definition of words. We call that word embedding. And then once we have that, then we can move ahead and say, take a look at the public forums, say Linux forums and other forums, whereby the public data is available to you, as in these are public forums which you can crawl and download and use that data, and use the data in order to build your bot. So basically, these are some of the ideas, but that's basically one of the things that that every individual comes up with in a very creative way. And some of the tactics that we use, let's say we are trying to build a face recognition system. So what we'll do is we'll take the same photo and we'll color it, we will apply all kinds of filters on it, and then feed it over and over again. That way we'll have different photos, some skewed a little bit, some gray, some in black and white, some in different colors, some with some more effects. And but the person remains same, therefore we can comfortably train the system with the same photo but different you know, the filters on it. So basically that's called data augmentation. So data augmentation coupled with crawling, coupled with transfer learning, you can achieve a number of things there, right? All right, so there are quite a few questions, and I think I should just move ahead and I'll come back to your questions later, because as I'm going through your questions, most of these questions I'm going to answer as part of my discussions. All right. All right. Okay. All right. Ashwin, was he able to explain data augmentation? No? We take the same data, take the photos of the data from various angles, and or you can say that, let's say we take a photo and we're trying to train the system with we are trying to create a system which can recognize faces. Well, what we'll do is first, instead of just taking one photo of yours, we'll just take a whole video, and we'll pick up like maybe say 60 frames per second from your video, and then we'll take the photos, we'll apply the effects on each of the photos. Then let's say we are applying, say let's say we took 60 photos of yours from the video, and we applied, say, 100 filters on it. 100 filters on it, meaning that 100 into 60, that means we'll have 6,000 photos of yours, right? So that's an example of data augmentation. All right, Raghavendra, I think I answered your question as well. Okay. A question is, GPUs are found in video cards. Where are TPUs implemented? TPUs are basically All right. So TPUs are separate architectures, probably the one that are, I think Google has implemented one of those. So those are, I mean, rarely available. So it's a new architecture on the same thing. Question is, does Google provide GPGPU environment? GPU environment we are not yet providing, and because that's extremely costly on AWS. But most of the work, what we are going to do in the class, can be done very well on normal 8-core processors. We are providing 8-core systems. All right. Okay. So our question is that we talked about applying machine learning in curing diseases like cancer. Is there a success in the field? Yes. The entire field of medical diagnosis is a statistical, or you can today say that is moving to machine learning. All right. All right. So let's move ahead. There are lots of things that I need to define because they are. Let me just move ahead, and we'll pick up your questions towards the end again. All right, because your questions are very important, and these questions probably would make sense to others when I discuss what is machine learning in more details and how it goes about. All right, so moving ahead, and here we go. So we talked about data and intelligence, and for data we need to gather, clean, and so on. So for gathering and collecting the data, we need IoT devices, crawling, and other systems. And for processing data, one of the things that comes up is the parallel computing is done using distributed or GPU or maybe the TPUs. Now, the traditional approach versus machine learning approach is what I'm going to talk about. Okay, so question is, how do we write a spam filter, right? So so I'm going to do the comparison between the traditional approach and the machine learning approach. I'm using the term deep learning and machine learning interchangeably because deep learning is a part of machine learning. So let's take an example of the difference between the approach. One is the classic approach whereby we write code, we write rules, and the other is letting machine figure out. How do you write a spam filter? Okay, classically, this is how we did it. We looked at a problem, we wrote the rules, then we evaluated those rules. In case it is successful and the evaluation is good, we launch it. Otherwise, we go back and analyze errors and then again study problems. So this is the manual way of doing it, figuring out the common frequency, figuring out the frequency of word manually, keeping all kinds of looking at the data, understanding the pattern by ourselves, writing code to detect the pattern, and so on. This is the classic or traditional approach we use. The problems, what do you think are the problems with this? Anyone? You can use the chat in order to reply, not the Q&A. So here, the writing rules is human part, that people are writing the rules, okay? And programmers are writing the rules. We are writing our own ifs and elses, that if we find this keyword, or if we detect this pattern, then we mark it as spam. The way we classically do the programming. Yes, that's right. Thank you for your answers. So I think there'll be large number of rules and will become difficult. Thank you, Santil, Pradeep, and Oliver, and Sunny. Wonderful, wonderful. Yes, yes. Great. Thank you, Raghvendra and Girish. And yes, so the problems with this approach is basically the problem is not trivial. Therefore, you'll have to you will have to write lots of complex rules. It'll be pretty hard to maintain those rules. And if spammers notice and they figure out that what kind of rules you wrote, right? Imagine that you figured out that all the emails that have for you written like this are spam, and they figured it out that you are blocking all such emails. They will start writing for you instead, right? FOR space U. And if spammers keep working around your spam filter, we'll need to keep writing the rules forever, right? And therefore, this approach, the traditional approach whereby we studied the problem, we came up with the rules, we would never be able to solve the hard problems like spam filters. Now, this is the machine learning approach. We study the problem a bit, and then we train our ML algorithm on the data. Let the data come in, we feed the data to machine learning algorithm, let it build the model. And once it has built the model, we evaluate that model, evaluate the solution. If it is working perfectly fine, you are happy with the measurements, you are happy with the performance measures, you are happy with the performance of it. Now, evaluating the solution, your scale could be different, my scale could be different. Maybe I don't want to even make the system mistake even 1%, and so on. So we come up with those evaluation parameters, and based on that, we evaluate our solution. In case it's acceptable, we launch it. Otherwise, we go back and analyze errors and then study the problem and train the model again. Right? So, yes. Question from Arun is, can the rules be intelligence? And system should create self-rules based on the data. That's exactly the machine learning is. When we think about neural networks and various machine learning models, that's what they're doing, looking at the data, creating their rules. And that's what, let's say, the systems like, there was a system like AlphaGo. AlphaGo was basically the computer algorithm that defeated the Go game, the world champion of the Go game. So the AlphaGo defeated the world champion of the Go game. And when AlphaGo was making the moves, it was making the moves that looked very, very lame in the beginning, very, you can say that very stupid moves in the beginning. I mean, the remarks of the world champion was that the kind of moves AlphaGo was moving were not something we ever move. Okay, so coming back to the point that figuring out that rules is basically the idea behind most of the supervised learning, we call it, and that's what we are doing in machine learning approach. All right, so all right, moving ahead. So this is the difference between the classic approach and machine learning approach. So these rules are what we call as models. Okay, so we feed the data we feed the data to the algorithms, they generate the models, and those models is what we call rules. And those rules can be quickly applied on new data to give the predictions whether some email is a spam or not a spam. So a spam filter based on machine learning techniques automatically learns which words and phrases are good predictors of spam by detecting unusually frequently patterns of the words, and the program will be much shorter, easier to maintain, most likely more accurate than the traditional approaches. Now, we can further automate the process. We have the data, okay? So we can further automate the process. So we can make it such that people start giving the feedback, and using that we basically keep on automatically learning. Just like when you mark a spam in your Gmail or in your Yahoo, they basically make a note of it that you are trying to mark something as spam. Okay, so you can make this whole process is automated, that as in when the feedback is coming in, you keep on improving. You keep on improving, and so on. All right. So the machine learning models can also help us learn, because they can show us like what they have learned, and we can basically utilize that learning in many ways. Okay. So basically, the machine learning models can help us learn more about the data in more meaningful ways, because the rules that system infers, we can also take a look at those and understand that, oh, these are the words, or these are the criterias on the basis of which it is deciding upon this span. Okay, so we study the problem, we train the ML algorithms, we get the solutions, we inspect the solution, and then we get the results. And using that model, we can also understand the problem better, and we can iterate further. All right, so that was the difference between the classic approach and the machine learning approach. All right. Okay. A question from Rohan is that how do we combine ML model to our app? You can call them ML model in your app by launching a service, you can create a web service to which you can make calls, and that's how you can utilize the ML model in your app. Okay. So imagine that you are trying to let's just continue with our email example. Let's say you are handling email system, and there you want to call your model, right? So you can basically load that model. Let's say you're using Python or you're using Django as for the web development, you can make the call. In case you have written your model entirely in Python, but you're using PHP, you can launch a web service to give the predictions, and your web app can call the web service. All right. All right. Okay. All right. Give me a second. Just a second, I'm adding my team. All right, so there are good enough questions. So let's okay, let's see if I can take it up a while later. These are good questions. So uh, I would like to move ahead a bit and then come back to the questions again. All right. Now we talked about so far what we talked about the basic definition of machine learning, and that I did using the Mario example. Then we talked about data and intelligence, and then we talked about we talked about a classic example of the spam filter. And all right, now there were classical ways of detecting the pattern in the data. There were classic ways of detecting the pattern in the data, and those were basically successful for quite some time. But when it came to detecting the complex patterns and doing the predictions on that complex pattern, the classic methods were not very successful, like speech recognition, the image recognition, and so on. And this is where the neural networks came into play. So neural networks are basically the computer systems inspired by biological neural networks that constitute animal brains. All right, so here's a boring definition. So they learn what we do in case of neural network is that we learn, meaning progressively improve the performance to do tasks, considering examples, as in whatever the historical experience or example we have. Based on that, we learn. And then generally without task-specific programming, meaning that when we are creating models or when we are writing the machine learning models, we do not use the task-specific programming. And using the neural network, we can do the predictions, let's say on an image, whether the image has a cat or not a cat. All right. So those kind of really complex tasks could be performed, could be learned from using a neural network. All right. So here's a simple example. Here's a simple example, and how does it work? All right. So a common question is that how does a neural network work? I'm going to take a really, really simple example that imagine that you are at a new place, let's say in a new hotel or a place where you are not sure that you are not acquainted with the surroundings. So you in this hotel, you go to the bathroom, and there is this tap, and on one side is hot water and other side is cold water. So when you at every point of time, what you do is you basically slightly twist the knob and check whether the water is good for you or not. And 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 basically this way you keep on twisting the knob until the water is okay for you, right? You keep on twisting this knob until the water is okay for you. Now, when we talk about deep learning of the neuron, right? Neurons, the whole layer of neurons, and so on and so forth. Each neuron is a very, very simple unit. Each neuron is nothing but a knob the way we are looking at the knob here. Each neuron is a knob. Okay, so we basically, by the way of program, we basically tweak this knob until we get what is expected. So we have the information that this is input, this is one input, this is another input, and this is our expected output, right? So we keep on twisting the knob until we get the right results, and that's about the way we do the training. So here, when we are going to take bath, before that we spend some amount of time on figuring out the best position of the knob, right? That's training. That's training a neural network, right? And once we are done with the training and we can comfortably take bath, right, we can just turn it on, and you don't need to keep on tweaking it again. So that's basically using a model to do the rest of the predictions. So this is an extremely simple example, a simple analogy to understand what does it mean by training, what does it mean by an individual neuron. So individual neuron is like a knob that you can tweak. Okay, basically the program, the optimizer, the algorithms, they tweak the knob in order to meet the expectation. So we have the historical data. When we say historical data, it means that we have input and expected output, specifically in these cases. So we have input and expected output. So we keep on tweaking these knobs until these knobs start giving us the results similar to the expected output. All right. So this is extremely simple. Now imagine that when you have, let's say, lots of inputs, like the person's image, for example, or the climate, the gender of the person, and so on and so forth. If you have many more inputs, then single knob will not suffice. You will need a bunch of knobs. And people figured out that when you align the bunch of knobs like this, you can do good enough predictions. But if you put more and more layer of knobs, right? When you put more and more layer of knobs, then you will be able to do better prediction. So here, these are the knobs. This is the input, this is the expected output, or you can say this is the output. So in the first phase, what we do is, given the historical data, we keep on feeding to it and keep on tweaking these knobs. We keep on tweaking these knobs. And once the knobs are, once these knobs are giving us the results similar to the historical experiences, or you can say when these knobs are giving you the great results, in those cases you'll basically stop and you'll say that, okay, my neural network is trained. Okay, now earlier basically simple neural network was what we were using because we were trying to basically increase the complexity of this one. And later on, we realized that if we basically put the layers of neurons this way, we will be able to do the better predictions. Okay, you can, the way we talk about the neuron is nothing but a knob. So what's happening is, we know the input. Okay, we know this is the input, that this is a person is a male, the hot water temperature is this much, and so on and so forth. So these are the inputs, and this is the expected output. Okay, that this much should be the flow of the water, and this much should be the expected value. And these are the set of knobs. Okay, so these knobs basically get the inputs from all, and we get the desired output. All right, so basically researchers found out that when you put the layers of knobs and layers of neurons, it gives you far better outcome. And on top of it, they figured out that we can actually figure out these knobs values, the point, figure out those values efficiently by the way of new set of algorithms such as gradient descent and backpropagation. Once we figured out that how to efficiently come up with these knobs, these positions of the knob, or how to efficiently tweak the knobs in order to get the expected output given the input, we were able to do the deep learning. All right, we were able to do the deep learning once we figured out this part, and this is basically the recent phenomenon. All right, so deep learning is being used by almost every company today, whether we talk about BuzzFeed coming up with your favorite food and so on, coming up with various titles for the blog, or when we think about Airbnb coming up with the various hotel prices and so on and so forth. All of that is done using deep learning, same model, the kind of model that we talked about. And similarly, Optimizely or Google or Pinterest or Facebook. So this was, these are various companies that are using it. And you can take a look at systems like Google Translate, AutoDraw, and so on. All of those are based on deep learning. All right, so let me go back here. All right, did this analogy make sense to you? So I talked about, I did not go through the classic route of defining supervised machine learning problem, unsupervised, and so on. I mainly talked about the one is deep learning approach, and then we talked about the artificial neural networks. All right. So basically, the idea is to come up with those combinations of the knobs such that we can get the desired output given the input. And that's exactly the neural network is all about. So, all right, and you can take a look at the Google experiments here. So there are good collection of URL. Okay. So good collections of experiments here. You can take a look at those and on this URL. Now, the other part is the TensorFlow demo. Probably second half we can keep it for questions, and I can go ahead in the second half. So here, let me just show you an example here. All right. So what we see here is that here, basically, this is the pattern in which we are trying to figure out a boundary or a model so that we can predict whether something is blue or green. Okay, imagine you have this data in certain form. This is the characteristic of one characteristic of the data. This is another characteristic of the data, right? And what we are trying to figure out is that based on these two parameters, whether it's blue or green. Okay, now generally what we'll do is if we are given the simple problems, so what we'll do is we'll draw a line, we'll draw and try to separate it. But this kind of scenarios where our data is complex. Okay, so here Here again, let me describe the problem to you, because in this case, the one thing that is not clear to many is the description of the problem. Okay, so imagine you have certain data set, and the way when we call the data over and over again, I'll just draw it for everyone. Okay, imagine that we are trying to come up with the salary. Okay, so we're trying to come up with the salary for next year. If my first year salary was 2,000, right, and second year was 3,000, and third year was 4,000, right, how much will be the next year's salary? Yes, anyone? 5,000, right? In this case, the pattern was extremely simple, so we all could guess it, right? Right? So, I mean, here we could basically see this is 2,000, this is 3,000, this is 4,000, and we basically draw a nice line, right? Now, if the problem is a little bit more complex, imagine that we had a little awkward data, and we had the data like, this is my first year salary, and this is my second year salary, and this is my third year salary, this is my fourth year salary. Now I can't really draw a line straight away, right? I'll have to come up with some line somewhere like this, correct? Now, further, imagine that we had to predict our chance of success based on two parameters. Let's say age and let's say height, right? And this combination of age and height means that we succeed or we get pay raise, and this combination of this combination, if my age is this much and height is this much, I get failure. Okay, if my age is this much and height is this much, then I get success. All right, and some combination of these, let's say it comes out to be like this. Okay, so in that case, if we have to come up with, let's say this is our given data, and if we want to come up with a model which can predict better, then our usual techniques don't really work that well, right? So we come up with these knobs, all kinds of knobs that are doing all kinds of magic, okay? And we apply all kinds of translations to it, and we let it run, okay? So you can see that it has figured out the pattern in it, and it has figured out this model. Now, once we have this boundary using which we can do the predictions easily, all right? All right, so I've gone really fast into the machine learning part, and you should also experiment a little bit on this playground. We will, in the second, so shall we start? All right, you can respond using the chat window. Okay. All right. A question from Rohan is that when I get this recorded session, because last time I attended your Hadoop session, I did not get it. So please drop me an email at reach@CloudX Lab. I'll share with you the Hadoop one as well as this one. Okay. Also, this session will be shared with everyone who has enrolled, and if we have the email ID. And also, I'll be publishing it on our YouTube channel of CloudX Lab, the video of it. Publicly, I'll be posting it. All right. Great, wonderful. So this was a quick example of what it means by neural network and how it works. And the core of the machine learning is to be able to detect pattern and do the predictions. Okay, and that's pretty much with respect to most of the content. Let me just walk you through the various framework. Now, to be able to tweak these knobs that we talked about, in our in a typical machine learning project or in a deep learning project, what happens is the neural network, we have hundreds of neurons or thousands of neurons. And in some cases, the total number of neurons is a million kind of neurons, and that takes a lot of computing, and we require a lot of code to be written there. And to be able to do that, we can use either TensorFlow. That's basically a library that helps us construct such kind of patterns, such kind of uh, layers of neurons, as well as your custom calculation paradigms, as well as, so TensorFlow allows you to do the creating your own library, as well as TensorFlow provides you the out-of-the-box ability to train the neural networks. All right. Similar is the case with Theanos, Keras, Caffe, and PyTorch. And using these frameworks, you can build systems which can do amazing predictions. All right. So basically, this is the first session, very introductory session of the course called Deep Learning with TensorFlow. We will basically learn, in the next chapter, we are going to learn TensorFlow, convolution neural networks, and recurrent neural networks, and autoencoder and reinforcement learning as we go ahead. All right. We will be, in these courses, we will be digressing we might be digressing from the actual topic. We might include more topics if those are needed. So this is, I'll go back. So this is the plan for this course. Here I'll be including PyTorch because people are asking for PyTorch along with TensorFlow. And also I'll be including extra chapter on the vision, computer vision, in which we'll be discussing the Tesseract, OpenCV, and other systems. Okay, so that's generally the plan. Now, I'm getting back to the questions of everyone. So a question from Girish is, let me just show it on the screen. All right, so that's pretty much with respect to the theory part. In case those who were having the questions related to the machine learning, feel free to ask questions, and I would love to answer all the questions. If needed, I'll pick up my slides wherever I find I need aids to explain my concept. A question from Girish is that, is TensorFlow platforms a platform of neurons that can train on top of GPGPU? So TensorFlow is like, you can think of it like a programming environment, okay, whereby you could define algebraic expressions, okay? So you could say things like, x equals y plus 10, and z equals x into 30, or some other mathematical operations, even though we don't know anything about y yet, or y yet, right? So we can define such kind of expressions using TensorFlow. And later point of time, we can say calculate z given y. when y is 10, calculate z. Okay, so when y is 10, x is going to be 10 plus 10, which is 20, 20 into 30, which is 600. Now, similarly, we could call the same expression and ask TensorFlow that what is the value of z when y is 3. So this is just extremely primitive example of the foundation of TensorFlow. We're going to do a lot of work on the TensorFlow as we go ahead. All right, those who have taken up, I'll just do a quick hands-on so that we all are on the same page. So in the CloudX Lab, whether you can use your Anaconda or you can install Jupyter locally, or you can use the lab on the cloud. Okay, so this is my home environment. My home environment might have lots of files. Okay, so here I'm saying Python 3. So this is the place where those who are new to programming don't get scared. It's extremely simple environment, and this is called the Python Jupyter Notebook. We have launched the Python Jupyter Notebook. It's a standard software. You can also download it and use it on your desktop, or you can use it on the CloudX Lab. Now this is where we type our code. So probably this is the most complex code you will write. So 2 plus 3, and you press Shift Enter to execute it. So it has given the answer as 5. So this is basically Python. This is basically Python. Here, when we are defining something like x equals 40 and x into 50, we basically are doing the things just like we do in calculator, right? So this is happening immediately. We are saying that x is 40 and x into 50, right? This is happening immediately. In case of TensorFlow, basically the calculations can be executed at later point of time. You can express our logic in terms of variables, just like algebra, and we can use that. So here we can start, let's say, TensorFlow, if you want to work with, right? So we have imported TensorFlow, and now we can start using TensorFlow, right? So using TF variable, we can start talking through TensorFlow. All right. So those who are interested in going ahead with TensorFlow, you can basically start using it here. Now, all right. So this is good. Moving ahead, and so this is basically Python as a programming language, which is extremely simple. And we have on our CloudX Lab, we have the Python courses for free. You can come over to, say, CloudX Lab here. And here you can do the free trial. And they are, like here, you can just start with Introduction to Python. Okay, those who are interested with this, the course is going to be in Python. Now, that was a quick introduction of how to get started with the lab. Moving ahead here, okay. So TensorFlow is essentially a place where we can write such kind of logic and get the results. All right. We'll be starting with TensorFlow in the next session, and we will basically learn how to use TensorFlow to do things. All right. A question from Henry is, do we need containers or Kubernetes to scale machine learning? Good question, but in case of TensorFlow, that can be done, but a better way would be that you set up your cluster and then probably use the distributed frameworks, maybe TensorFlow distributed or Spark, and then you can scale machine learning there. But the challenge with the algorithms like the one that we use with deep learning specifically for training neural networks. The challenge with most of them is that they are non-distributable, meaning we can't basically do the things parallelly in some of the cases, but some part can be done. So you can either use TensorFlow distributed, or you could, for classic machine learning without the neural networks, you could distribute using, say, Spark ML Lib and so on. All right, but probably people are doing that container-based execution of machine learning model. That's something has started, and there are a couple of frameworks which I was checking out. They were basically using the containers and Kubernetes, but the more practical way is, if you are having a cluster, utilize the cluster to do classic machine learning. Utilize say GPU to do the deep learning. That's the general strategy. All right. A question from Pradeep is, I believe I read this in Kera's talks by Francis Cholet. Never understood it completely though. Okay. I think you were talking about neural networks. A question from G is that, do we need data to be in particular format? Or if so, it's structured data dependent. So if we are working on a machine learning project, the first thing we do is we translate our data into a tabular form. That is something the de facto with entire thing. Okay, so whatever data we have, what we do is, first thing we do is we convert it into a data table or data frame, right? Like in the case of the salary example, you have got age and you have got experience, number of experience. You have got the let's say age, experience, and what do you call the height, right? And then there is a salary. Okay, so this salary is basically something that you want to predict, and this is called the label. We call it label, and these are called the features, right? And this is one instance that for a person with this age, with this experience, this height, the salary was this much. Okay, for a person of this age, this experience, this height, the salary was this much. So these are called instances. Okay, so what we do in case of machine learning is that we convert our problem into this kind of format. Imagine that we are doing the predictions on cat or not cat. Let's say given a photo, we want to predict whether it has cat or there's no cat. So what we do is, in that case, each instance is going to be, okay, in that case, what are going to be the rows, right? Anyone? So cat or not cat? Anyone? So in case of cat / not cat, example, what are going to be the rows? This is going to be one example, right? One example. And the columns are going to be pixels of the image, right? These columns are going to be the pixels of image, okay? Okay, and the label is going to be cat is cat, right? It's going to be, all right, we put the photo as image and we say, okay, this is a cat, true. This is not a cat, this is a cat, this is not a cat. So basically, this is going to be the label, and this is called label, okay? Whereby we mark that given this data, given this image of the person, whether it's a cat or not a cat. All right. So basically, we convert our data into that format. Okay. A question from G is that not all data can be structured format, right? Yes. If you have like a huge amount of data, in that case, it may not be. It may not be. It may not be readily available as a tabular format. And that's where the ETL comes into play. Using extract, transform, and load techniques, we can convert the unstructured data into structured. And this is where we use the big data tools. When you have a lot of unstructured data, converting that into structured and clean format, we need to do a lot of processing, specifically when you have, say, terabytes of data or petabytes of data. In that case, what you do is using a big set of computers, you clean this data, convert that into tabular form, create the instances and the labels and so on. And that's how you basically come up with, okay, basically come up with the table. All right. Now coming up with moving ahead. Okay, so here I was talking about, there's a question related to that. How does the table work? Okay, so once we created this table, we feed it to any of the existing algorithms. We call the fit on that algorithm, meaning train the algorithm. Oh, my handwriting is bad. So we basically call, say, dot fit on an algorithm. Okay, it generates the model. Model could be a neural network model based on what algorithm you are calling. Okay, and once we have done, it gives the model, then it can start doing the predictions. All right, so here real-time data will come in, and we are given a row, it'll be able to say yes or no. All right. So given an unknown instance, given a pic, it'll be able to, given a picture of something, it'll be able to give you the is cat yes or no. All right. So the core of the game of the machine learning, here I'm talking about something called supervised learning, specifically when you have this clear training data whereby we have labels saying that this image belongs to a cat, this image is not a cat, this image is a cat, and so on, right? This is called supervised learning. In the supervised learning, we create this data and then we feed it to the algorithm, and the algorithm basically gives us the model. Using this model, we can classify a given image into a cat or not a cat. All right. All right. A question from Pradeep is that could you explain the basic vocabulary such as deep learning in deep learning, such as epoch? Yes, those we will talk in more details when we go ahead. All right. In the sessions there's the third chapter actually. All right. A question is, will you teach us in course how to convert? Yes. Some of it is yes, but we run a separate course called Spark with Scala. There we learn how to convert unstructured to structured and so on. Okay. And in this course, we are going to assume mostly that the data is in structured format. If it is not, well, at most what we're going to do in this course is load the data which is tab separated, comma separated, and so on. In this course, we're not going to cover that part because that's a whole science around it. All right. Great. There are quite a few questions. There are 32 questions. I'll be answering these questions, and I might go back and forth. So be with me. I'm sure that this is going to help you. Okay. All right. Let me just go back to beginning and start. Question from Munir is that what is the prerequisite for deep learning? In this course, we are assuming that you are comfortable with Python. And if not, you can just go ahead with the self-paced course that is there on CloudX Lab so that you can become comfortable. All right. And the prerequisite, if you are asking that what are the prerequisites to get started with deep learning, is that you should have data and you should have your problem statement. You can start basically using the existing frameworks and start learning from the data and doing the prediction. Question from Raghvendra is that on what basis we choose algorithm? I mean, what factors or data influence in choosing the algorithm? Okay, so I should show you. There are, this question is hard, and let me see if I can answer it simply. In the classic sense, we spent a lot of time selecting the algorithm in classic machine learning, right? General thumb rule is if you need a model that can be explained to the All right, sorry, I got disconnected. Okay. All right, sorry, I got disconnected. So let me just go back where I was. All right. So, okay. All right, yeah. So I was talking about the rule of thumb, and I've clicked on somebody's question. I don't mind, Sunny. I'll answer your question after this. So first rule of thumb is that if you want transparent model, we want to go with decision trees. If we have smaller data, we go with SVM. Otherwise, the other general rule of thumb is we try all possibilities. We try neural networks. We try the all permutations and see which one is performing better. All right. If you have good enough data, we use the neural networks. If we have smaller data, we can't really get great results if we have very tiny data. In that case, we'll have to go with core machine learning, okay, instead of going with the deep learning. So I talked about three things. One, if you have huge data, you can use neural network. If you have smaller data, you can use core machine learning. If you have even further tiny data, you'll have to use things like SVM, which can give you great results. But But if you have, but if you are, you'd require an interpretable model, then you'll have to go with easier models like decision trees, for example, whereby you exactly know what's going on underneath. All right. So those are the ideas. Now, let me take up the next question from Sunny. Question is, so we only give one order to the machine learning system. Example, get the highest score or count the number of occurrences of text without suggesting it how to do it at all. That's correct. That's correct. So essentially, when we talk about machine learning, the idea is that we tabulate or we establish the historical data along with our expectations, and we feed it to the machine and then see whether it's able to predict on unseen instances or not. Okay, that's the core idea. So that's right. Now a question from Oliver is, we can store it anywhere like a database about the data? Yes. And you can store the data in database, file systems, and so on. If your data is in tabular form, you can put it in file system. Okay. And in case your data is like in a tabular form, you can put it in database. Otherwise, if it's like a complex data and doesn't have a tabular structure, in that case, you'll have to put it in a file system. Okay. Another question is about intelligence. Don't we need to define a set of rules? For example, to determine a text is A, there has to be a pattern to identify it as a letter. Good question. So question is, don't we need to define a set of rules? For example, a letter is A, there has to be a pattern to identify it as a letter A. So basically, we essentially do not, in machine learning or deep learning, we do not teach the rules to the program. Instead, we convert our requirements into the formats that I just described, okay, like the one that I talked about here. So in your case, the example that we are taking right now, is the volume low? You can reply using chat window. Okay, so here I'm trying to answer Oliver's question. So question is that what if we have to whether given this, let's say this drawing, whether it's A or B or C or D, right? How would we build that? So a classic problem on the same lines is called MNIST, okay? MNIST, okay? Whereby we do this for the digits, okay? So what we do is we basically will convert the problem into this structure whereby each image, it will be converted as 1 pixel per column, although it's different in different cases that I'm not going to talk about right now. Like for example, convolutional network, the image is not going to be like this, but let's be with this format for now. Okay, so basically we convert our input data that this image is A, this image is B, this image is C, and so on, right? This column could be a label with a real text, okay, real character. Now, once we have done that, we'll basically feed it to the various algorithms and compare which one is giving great results or not, because we know some of the data. So first of all, we'll gather all the images in various handwritings of A. A as well as B as well as C. Then we frame our problem in this format. Then we feed it to the algorithm, and then we'll have the model, and we'll give it unknown instances and check whether it's performing good or not. All right. So we don't have to. This is a interesting part about the story, that we don't need to really look at what is it about. For example, in one of the cases, what we were trying to do is looking at the image. We were looking at the molecular structure of molecular structure of something. We were trying to come up with the strength of that. And I had no clue about the molecular structure as such. What does it mean by black or white or something? So we basically fed it to the machine learning, telling that historically these are the images and these are the strengths, and from which it will learn and then start predicting. All right. So that way, even though I had no clue about the molecular structure and the relationship between molecular structure and the strength, but my machine learning algorithm was able to bring the prediction to close to 90%. Okay, so that's something great about machine learning, that you don't need to feed the rules by ourselves. All right, great question. So I'm moving ahead to the next question. I hope I was able to answer your question. Okay, continuing to this question, there is one question from Narsima. Will this be feed a series of images like cat, or is it read from the pixel like heat maps? So we'll be basically converting our image into columns, and okay, and we'll be will this be, let me read the question again. Will this be fed as a series of images like cat or not cat? Or is it read from pixels like heat map? So we'll be basically converting our data into this format. Okay, whether it's a heat map, whether it's anything, there's just additional advantage that you can give. Okay, but generally we don't get into doing the manual manipulation. Instead we add more and more the filters and things like that into the model itself. Specifically, if you're going, let's say I have to do A or not A, so what we'll do is, instead of we coming up with all ideas like coloring it and so on, we let the deep neural network do that. We basically, in the convolution, there is a way of specifying all kinds of filters. So we'll let that filter be applied there. Okay. So, all right, wonderful question. So moving ahead, a question from DJW is backpropagation in neural network the same as reinforcement learning? So yes. So reinforcement learning, if we are implementing using neural networks, then we'll be doing the neural network. Okay, so reinforcement learning is part of the machine learning part. Like in case of Mario, we did the reinforcement learning, and there we basically we gathered the data and continuously learned from the data. And backpropagation is a way of figuring out various weights of various neurons, such that we get the desired output. All right. Now, moving ahead question is all right. So most of from now on, I'm going to mostly answer your questions. Feel free to ask questions, and feel free to ask any question. We still have around 40 minutes. All right. So all right. So question from A is, how does it recognize sound corresponding to alphabet? What kind of correlation is provided to recognize the words? All right. So yes. So it's a good question, really good question. So question is, how do we convert the sound, the problem like sound, how do we convert a problem like sound into the tabular form, right? That's the question. So again, I will stick to the tabular idea. Okay, so how do we represent the sound as sound as a table? Let's say sound of A. How can we convert it into the row? Right? This is one row and this is another row in the table, and this is another row. And this is basically the label on it. This is another label. Okay, so we call them features, and this is called label, and these are called instances. This is called instances. Perfect. So question is, let's say sound of A, and the label here, we know that this is A. And how do we convert the sound of A into this kind of, the columns? Anyone? Use the chat window to answer. Anyone? Yes. So we could convert it into probably, okay. Yes. Frequency and amplitude, convert it to text first. Okay. Okay. That's very interesting. So right. So what we can do here, there are many ways of converting sound, but how you start is basically you take a sample of certain size or a width and convert it into frequency at various points. This is 0 second, this is 0th millisecond, first, second, and third, and so this is like really primitive way of expressing it. And you can further break it down into things like moving window here, basically computing the average of the sound at, let's say, at a window of 10 milliseconds and so on. Okay, or 20 milliseconds and so on. So there are many ways, but the idea is that we start here. We start with gathering the instances and the labels and the features. Okay, and then on top of it, we can apply all kinds of tactics, right? And also we can apply, say we can also apply the convolution neural network or on a sound. Yes, it has been tested that it works, and so on. We could merge multiple columns. We could do multiple kind of things on this. All right. So but we start here. All right. Great. Moving on to the next question. Question from Leo is, is there a bottleneck of the learning, like when the program stops learning? Good question. So every algorithm, every strategy, every model has their own limitations, right? Some of them are right. Some of them can predict one form of pattern, and other can predict other kind of pattern. But after a point of time, when the data is not sufficient, every model kind of stops. Okay, and it could be a function of which algorithm are we using. It could be function of what kind of data we have. All right, so yes, so and sometimes even the algorithm, let's take a case of neural network. What happens in case of neural network is that when you have many layers and when you are trying to train it, after a point of time, the change stops going from right hand side to the left hand side. And that is also basically, there are multiple ways of overcoming it. So I would say that it all depends on what algorithm you're using, what strategy you are using, and based on that, you take a corrective measure. If you're using a neural network and your system has stopped learning, in that case, you will have to take a look at whether there is something called diminishing gradients problem, and there's something called exploding ones, and so on. You will have to take a look at what exactly is going on there. Based on that, you take your corrective measure. All right. Okay. A question from Irfan is stops going from right to left. Okay, good point. So I think I shouldn't have mentioned it, but we'll talk about this when we go into more into neural networks. The way we train the neural networks is that the way we were tweaking the knob, we were tweaking the knob in isolation. There was only one knob, but if you have many knobs and many layers of knobs, so first you tweak the rightmost ones. Okay. All right. Let me just take you quickly through this. Okay. So in this kind of thing, there was one knob and you quickly, tweaked this knob and came up to a position, right? Smartly. But if you have so many knobs, which one do you tweak it? Or when you have multiple layer of knobs, how do you tweak it? This general strategy is that you tweak one knob and keep everybody frozen. You only tweak one knob at a time, observe the impact on outcome, and then you tweak it further. And the idea is that we start from the right-hand side, then go to the left, and we keep going to the left. Okay, so first we tweak these knobs, then these knobs, then these knobs, in order to come up with the best outcome. All right, so this is basically what we call back propagation. We propagate the change from right-hand side to the left-hand side. Okay, Irfan, does it make sense? A question from SAMG is that how do you recognize that the system is giving wrong results? Good question. So we break down our data, this data that we talked about here, we break it down into something called test and train. Okay, we break it down into train and test. Okay, on training data, we do the training, we train the system, and using test, we compare whether the results of the model is good or not. All right, thank you, DJW. Wonderful. A question from Godfrey is that, are you able to go through all the outline you displayed in the beginning? Time is almost up and we have not started the practicals yet. So today we are going to not go into the practicals. Today was the idea about the introduction to deep learning. And from the next session onwards, we will start with the TensorFlow. Okay, so let me just keep everybody in the same context. All right, here, this is what we were planning to do today. And yes, I'm trying to answer everyone's question because I think the questions are the most important part of these sessions. From next chapter on, next session onwards, the whole class is going to be mostly hands-on. So yeah. All right. I hope that's okay with you, Godfrey. All right, we have still 30 more minutes. Let me answer some more questions. Yes, you will get the session links and everything. Okay, a question is practical would be really good, even if the basic one, with few lines of TensorFlow code in TensorFlow. All right, take a look at the, right? I could actually show it, but I promised not to use code today. Okay. All right, so I'll just show you my GitHub repository. All right, okay, so all right, I hope the people who are from the non-technology background, they would be okay with this. And I don't want to get into something really complex. Just want to do a basic one. All right. A question from Uma is that what is the prerequisite to handling TensorFlow? I'm familiar with Python, attending the lecture on deep learning. Yes, of course, you can. We'll be learning TensorFlow nevertheless. Okay, so I'll just show you how it looks like. It's pretty simple to code in TensorFlow. Okay, you can take a look at our GitHub repository. Just search for GitHub CloudX Lab. You will see the GitHub repository, and that contains most of the code. All right. So here is an example of, let me just skip this part. All right, so here. So this is the basic program in TensorFlow. Here we are importing TensorFlow, right? We are saying import TensorFlow and STF. TensorFlow is available in R, available in Python, and available in other languages like Java, right? You can define a variable like this in TensorFlow, like x equals tf dot this, and y equals tf dot variable like this. And then we can define in terms of this, we can define f, the outcome, in terms of x and y. We are saying x into x plus y. Now this is more like algebra. Okay, this is more like algebra. And to run it, we need to run it like this. Okay, we have to say session dot initializer and so on, then we run it. So it looks like very clumsy that we're defining x in this way, y in this way, and f in this way. And then finally, to run f, we had to go through this, right? We had to initialize x, y, and then we did the run and did the close, right? So this is the basic one, basic example, and we will go into more and more details and understand why it is the way it is. So essentially, if our classic programming was numeric computing, you can think of TensorFlow way of doing things is algebraic way. Okay, we define the entire thing in terms of other variables, and at later point of time, we fill in the values and do the computation the way we are doing it here. We are saying that f is x square y plus 2, right? And at later point of time, we are evaluating it and then running it. Okay, so that's about probably the basic one. All right. So I'll get back to answering your questions, and you can go ahead. And in case you have already opened the notebook, your notebook, you can try running it this way. All right. All right, I'm just copy pasting it for all and just run it as hello world. Perfect. Now moving ahead. So moving ahead with the questions. A question from Nagesh is, what's the difference between supervised and unsupervised? Supervised is the cases that we have talked about, thereby we have certain amount of label saying this is a cat, this is a dog, this is a man, and so on. Those kind of machine learning problems are called supervised machine learning problem, where there is a label available to compare. In case of unsupervised learning, the problem statements are generally like this. Given this data, can you divide this data into 5 buckets? Given this data, can you figure out if there were any fraudulent transactions? So essentially, unsupervised learning is all about detecting patterns in the data where there's no label given to you. Okay, so that's a difference between supervised and unsupervised. A question from Arun is, could you please give some example of meaningful problems with games automated driving is moving left, right is a function of the problem? Question from Arun is that, how do we fit what we learned so far as the how do we fit what we learned so far into the larger problems such as automated driving? Okay, so imagine the case of Mario game. I hope the Mario game is more practical problem to you. So Mario game, that the same thing that we talked about here in case of Mario game, each pixel of the screen is one column. Each pixel of the image is one column, and what key did we press is also one column. And what score did we get? What score did we get is the label. So given the pixels of the screen as column and the key that we pressed, what is the outcome? That's how we look at the problem, right? So this is the score. This is the instance, each of the move, right? At each of the move, what was on the screen, and what key did we press, and what score did we get? So that's one example. But in larger problems such as automated driving, we need to combine multiple problems into we need to create the larger system using multiple parts. Okay, such as in case of automated driving, you have to look at the road, right? So first is determining, given an image, determining where are the people or where are the things. That's the first step. And then, given this information, should we turn or should we not turn? If we are going to turn, at what angle should we turn? So there are lots and lots of parts to a larger problem such as automated driving. Okay, that's why we have taken a simpler case. But be assured that most of the problems in any of these systems are basically either programmatic, okay, whereby given something we have to do something programmatically, or based on the machine learning. Okay, so larger problems are composed of many smaller problems. All right, a question from Oliver is, for the GPU, do we need to write code in a shader since shaders are read by the GPU? That's right. So basically every GPU, the way, let's say we are going with say CUDA or other systems, we need to write the code which is suitable to them. But good news for us is this. The TensorFlow, PyTorch, and other systems, those are basically abstraction layers on top of GPU, meaning you don't have to intermingle with the GPU by yourself. They automatically divide the work internally. For example, when we are writing these expressions, mathematical expressions in say TensorFlow, when it executes things, it automatically determines which parts can be done in parallel. All right. So that's a good news that we don't personally, individually have to interact with that, right? The only thing is you have to organize, structure your code in such a way that it can internally break it down into parts. All right. Question from M. Ramchandra is that what is the difference between TensorFlow, PyTorch, Keras, and sklearn? So all right. Okay. A question is, what's the difference between TensorFlow, PyTorch, Keras, and sklearn? Between these frameworks, they all are made for different. Scikit-learn is far more different than others. Scikit-learn is basically the core machine learning library. Scikit-learn doesn't have a deep learning network as of now. Okay. While PyTorch, Keras, and TensorFlow all are basically similar in the nature, and so on. Okay. So if you are using a deep neural network, you can't really use scikit-learn. But if you are using the classic things like classic machine learning parts, then you can use scikit-learn. If your data is smaller, you can't use deep neural network. In those cases, you will be using classic machine learning. In that case, you will be using the scikit-learn. Otherwise, you can use TensorFlow, PyTorch, or Keras. And a question from DJW is that scikit-learn has multi-layer perceptron algorithm. Is that the same as neuron? It is similar, but it's not that flexible. You can't really do much with it. You can't do convolution like image processing. You can't do the reinforcement learning and so on. Right? It's very, very basic one. Good question. A question from Raghvendra is, might be out of topic, but curious to understand what's the relationship between AI and machine learning, blockchain, and quantum computing. So relationship between AI and machine learning is this. AI is being able to make machine behave like humans, right? With respect to perception and so on. So AI is more like an objective, right? Which is achieved. The AI is achieved using classic programming, rule-based programming, and the machine learning and so on. So machine learning is one part of the puzzle to achieve AI. Okay, for AI, a lot of work is done. Like, for example, if you think about Alexa is behaving like, Alexa from Amazon is behaving like human, right? So that's an AI system. Now, to build Alexa, there's lots of rules written. If this is this, then do this. If this is this, then do this. If user says this word, then do that. So there's a lot of rules as well as machine learning. Both have gone into it. Recognizing voice is part of the machine learning, while based on the word, triggering something could be rule-based as well as based on machine learning. Now, blockchain is entirely different, distributed. Basically, it's a distributed data structure whereby integrity is maintained. While quantum computing is a new wave of computing that is not yet practical, but the idea is that we would be able to achieve magnitudes of fast computing using using quantum computing. All right. So quantum computing could help us in doing machine learning better, because machine learning requires lots and lots of computational power, and quantum computing would be a boon for machine learning. All right. Our question is, can we assume intelligence is a collection set of rules? Correct. Intelligence is collection set of rules, specifically the rules that are auto-inferred. Nobody created these rules by sitting down and curating. So intelligence is being able to predict something or being able to recognize a pattern. What are the best tools for cleaning text data? Is there any threshold for deep learning model? For instance, deep learning will not be accurate if data is less than that. Yes. So the threshold with respect to deep learning is that if the data is small, it is not great. Also, it takes long time to train a complex model. What are the best tools for cleaning text data? The best tools for cleaning text data would be probably the libraries such as basically regular expressions could help you a lot, and a programming language could help you a lot in cleaning text data. And in case your data is bigger, using Spark and other big data systems could be quite useful. A question from Bala Gwesi is that are these tools listed specific to each mode of parallel computing, or are these tools can be used in any three models? So these are those tools that I talked about were specific to the mode of parallel computing. A question from Ali is, which of the machine learning AI tools currently in the market, TensorFlow, Caffe, can be used for reinforcement learning? Actually, both TensorFlow and Caffe provides you the ways of reinforcement learning. Reinforcement learning is what? Like the one that we talked about earlier, where we were using Mario, that was reinforcement learning. What is reinforcement learning again? Whereby we are taking a step, getting reward, taking another step, getting reward, and so on. That's reinforcement learning, utilizing the past learning in the current state also. Okay, just like a robot does or Mario did, and so on, the continuous learning systems. A question from Craig is that if we incorporate supervised learning, though, can we still argue prediction? Also, would supervised learning be a good use case for cleaning processing of the data? Use unsupervised learning, sorry, I read it wrong. Okay, let me go one question at a time. If we incorporate unsupervised learning, can we still argue prediction? Not really. It will be very hard to do that. Though question is that what is unsupervised learning, right? Given a data, let's say we have to break it down into two classes. Given the set of transactions, we want to say that these are very outlier transaction and these are not outlier transaction. Nobody is defining that these instances are outliers, right? So what we do in such cases is that we basically look at the data from certain perspective and see in how many clusters can be formed. Okay, so basically if we have formed the cluster, then we can look at existing data and say that, okay, how is our existing data clustered, right? So we can't really define precision, like we can't even define the accuracy in terms of unsupervised learning. So we can't really measure the accuracy of prediction. Okay, would unsupervised learning be good use case for? Yes, unsupervised learning could be used for cleaning pre-processing data, such as we look at the data, we break it down into smaller form because we figured out that there were some outliers which may not be useful, so we remove those. Also, we look at the data, and in an unsupervised way, we reduce certain number of columns, reducing certain number of columns because we realize that lots of columns are useless. That's also part of unsupervised learning. All right, so yes. So unsupervised learning could be used for cleaning or becoming the feeder for the supervised learning. We could feed the outcome of unsupervised learning. All right. What are the measures techniques to measure the quality of data? This is hard. This is hard. So one way is just looking at the variance of the data. Then we could do the pre-processing of the data, such as doing the component analysis, principal component analysis, and observe how good is the variance and so on, right? If there is one column which is not changing at all for all the instances, that column has the same value, it's better to delete that column. If let's say there's a column which is just varying randomly, it has no, let's say we draw the conclusion at the end of the prediction that this column is not useful, okay, then we can remove those columns. So it's hard to speak on the quality of data before running the algorithm on it. All right. Because when your algorithm is not working great, you can always say that the quality of data is bad or the algorithm is bad. Okay, it'll be really difficult. One way is just observing the correlation of the input with the output. If there is some correlation, it should be possible to come up with some result. But if there's no correlation between input and output, the chances are that your data is bogus. How do we determine which is the most appropriate model? I think that we discussed earlier. It's actually a hard problem, but yeah, I think we have already discussed this part. Question is, can we use data aggregation servers from other companies to feed AI, like some open project? Should we buy the data if it's not freely available to us? Okay. Can we use data aggregation servers from other companies to feed AI? Yes, we can, but just take a look at their policy. In case the policy is not allowing, feel free to buy in case needed. All right. So, will you be discussing RNN, CNN, or LSTM? Yes, in this course, we will be understanding in detail about RNN, CNN, and LSTM. Who decides the rule? It's the computer algorithm that comes up with the rules. Okay, a question from Girish is, so do we need to define the basic moves that can be composed into different composite instructions by the machine, or do we just show the machine the interface and it also figures out? Okay, so basically those basic parts, like what are the keys that we need to press, where is the score stored, what does it mean by the features, which is something that we need to define programmatically, that the image on the screen is one of the features, as in one of the set of features, and the keys that you pressed is another features. All right, what algorithm sets would you use to create a spam filter? What algorithm sets would you use to create spam filter? I would actually try all possible algorithms that are available and then see which one is giving best results. Even though it has been known that there's something called Bayesian algorithm that actually performed far better, but long back. But now everybody uses the deep neural network. Okay, so a question from Pradeep is it's something like this: classical machine learning is rules plus data and answer. That's right. And deep learning is answer plus data equals rules. That's right. Okay, a question from Raghavendra is that is in unsupervised learning, what rules are referred to? Okay, in unsupervised learning, what rules are referred to is that boundary which is dividing the clusters. That's called the model. Okay, a question from Ashwin is the spam filter can be treated as a simple clustering problem. On what basis do we decide whether to go with clustering or deep learning? Okay, so all right. So basically, it all depends on how much data do you have. If you have used data, you should go with deep learning and figure it out. All right. And spam filter is not a clustering problem because it has labels. We have the labeled data saying that this is spam, this is not a spam. So it's a supervised learning problem, and supervised learning problem can be solved using any of the supervised learning algorithms. Is there usually a success or failure prediction percentage that ML models account for in the feedback? Is there usually a success or failure prediction percentage that ML models account for in the feedback? Is there usually a success or failure prediction? Yes, of course. Whenever the training is going on, that success and failure prediction basically is the one on the basis of which the models are trained. Is there usually a success failure prediction that ML models account for? Yes. So if we are, there are basically two kinds of machine learning problems. One is called supervised, and another is called unsupervised, though there's something called semi-supervised. But the main two kinds are unsupervised and supervised. In case of unsupervised, you don't have a success or failure kind of criteria. But in case of the supervised, you do. All right, TensorFlow fits best for NLP, image processing, or other prediction tasks, and TensorFlow will use more CPU or GPU. It depends. You can switch between CPU and GPU. TensorFlow is the foundational library which can be used, using which you can create many kind of models. All right, and it contains a rich enough library for now. All right. A question from Ashwin is the spam filter can be treated as clustering problem. Okay, I think this we talked about. All right. A question from TM Bashimov is that can you explain word to vec? Though we have word to vec in the session in this class towards the end, we go into the understanding of word to vec. But if you want, you can stay back in this session and I can answer your question. All right. Okay. Harshita's question is, what do you suggest if we don't find the data sets only? Do we create our own data set? Is it not tiring process? What do you suggest, how many manually label such data? So yes, that's the hardest thing. So when you don't have too much of data, you can go for, if you have smaller data, go for data augmentation, or you go for the um, data augmentation or transfer learning, or you basically do the crawling of the data set from various places. If none of this is possible, then you don't have any other choice than gathering your own data. Figure out smarter ways to gather the data. And yeah. Can I extract a price of commodity from a scanned image? Marketing brochure using this technique. Could you please share something? Yes, you can do that. You can actually, you can do it even without training. You can just use OpenCV and that can help you with that. All right. Today we did not do much of hands-on. I just showed hello world. Chatbot or anything. Okay. All right, that part we have not done much. If if I want to use ML to predict something as complex as cooking and doing house show, do I need very expensive hardwares? All right, so one more thing I want to tell you is that lots of the manual movements, or the ambulatory movements, can be done by the way of using simulations. Like Facebook has made their simulation engine public. I forgot the name. So what you do is you basically create a geometry, and you let your bot in that simulated environment, and your bot will get the visual images and so on. That way your bot can learn about collisions and so on. So if you're doing building a bot for doing the house chores and so on, you can actually train that bot in that simulation model without physically gathering the data. That's another thing I want to tell. All right. What's the difference between Keras and TensorFlow? TensorFlow is more foundational library, while Keras is a set of good algorithms, but you can do the work in both. All right. And Keras is also far more simplified library API. Okay, a question from Ravi is the code shows that the reset graph is not defined. Please take a look at our GitHub repository. There is a full code on the you can take a look at, say, here. Okay, just take a look at this one, that will help you. Okay, so here, take a look at the TensorFlow one. All right. A question from Henry is, do you think blockchain is going to leverage ML? Maybe, maybe not. All right. Probably every domain is being impacted with machine learning and deep learning. So maybe for some, maybe blockchain fraud detection somewhere, they could use the ML. All right. Almost every computing branch is being impacted by ML anyway. Question from Giri is, can quantum computing be achieved in future? I have no clue, but I'm optimistic. Question from Henry is, when are we going to reach singularity? All right. Again, that fear has been there for a very long time, even when the electricity was invented or the computers were invented at Alan Turing time. So there was a huge fear about the machines taking over and so on. All right. A question from Girish is cryptocurrency Bitcoin done using machine learning? No. They are independent branches of computing. There we don't really give predictions based on the data. Question is deep learning code on GitHub designed for GPU? It can run on GPU if you have configured TensorFlow to run on GPU, but I've not tested on GPU yet. How do you measure the quality of algo model? We basically have our criteria. The one which is giving more precise prediction is better model, and the one which is not giving precise predictions is not a good model. Are we going to program in parallel? Usually in our classes, we do the program usually in parallel, all of us. And how is data application important in healthcare analytics? All right, in healthcare analytics, everything is based on, there's a lot of data, and when you have a lot of data, you can definitely do lot of machine learning or analytics or predictions. All right, so in healthcare analytics, almost every part is going to be impacted or is already being impacted using machine learning. All right, is in response to your answer, when you define the keys, do you need to or not map, say, word W with jump? Okay, what is the definition here? say for W. Okay, so basically those when we say keys, in case of our Mario case, we have like lots of each instance definition is the whole image on the screen is one full instance. Each pixel is a column, and on top of it, one of the features is which key was pressed. Okay, which key was pressed. All right, it doesn't matter up means jump or no. We don't map anything with up, that up arrow key means jump, no. We just tell that when this was on the image and this key was pressed, I got this score. When this was on the screen and I pressed this key, I got that score. That's all. Okay, that's all. That's how the Mario example was trained, the one that you saw in the beginning. Yes, we are wrapping up, and I'm just going to answer the remaining questions in a couple of minutes, and then that'll be it. How about SpaCy compared to TensorFlow? SpaCy is good for, there is a library called SpaCy, you can try that out. That basically is essentially great for natural language processing. Okay, so while TensorFlow remains as a framework to create algorithms, while spaCy is one such algorithm, or you can say bundle of algorithms to do predictions on or do natural language processing. All right. A question from, I would like to ask, what domain would you advise graduate data science to fit in? All right. So if you are a graduate data science, I would say that make sure that you learn the neural networks, make sure that you understand the graph computing. That will help you build various kinds of models, irrespective of the domain. Good news in today's world is the way computing was implemented irrespective of the domain. Similarly, the machine learning models are going to be implemented irrespective of the domain. So a person who is trained in machine learning can work in many kind of domains. I mean, I've solved the problems, like, for example, a material science problem using machine learning. I've solved recently a problem related to the medical field using machine learning, and then the e-commerce one. So a person who is from the machine learning background, they can work in almost every domain. A question from Sunny, are companies' decision-making system based on machine learning? It can be done, but I'm not sure who is doing it yet. It can be done. A question from anonymous attendees, I would like to ask, what domain would you, all right, this I have asked. Okay, so I would say that do not, get the understanding of machine learning really well, and that then the knowledge of the domain will basically be an additional advantage. Okay, an additional advantage. Are there machine learning programs that does something like Python programming to achieve some task? Yes, people are trying to do that, and yes, the programs, I'm not sure if the neural networks have become so powerful that they could come up with the Python programming. But if you take a look at the way the neural networks and everything is designed, we are here, as you see it here. Where is the diagram? Oh, it's not there. Yeah. All right, this part. Yeah, if you think about it, this is actually, you can think of, if you think of these knobs, instead of knob, you think of them as gates. okay, AND gate, OR gate, NOT gate, and so on. So this is essentially an example of automatically creating a programming structure. So it should be possible. So if you think of these knobs instead of normal knobs, you think of them switches, right? Just like AND switch, NOT switch, OR switch, then you'll think of this as a large program in some way, all right? Question from Rajesh says that in programming side, which programming language do you suggest? I would strongly suggest go with Python. You can not only do machine learning, but also can do the web application programming. A question from Mohammed is, can you give me a brief of big data science and its application in healthcare and medical challenges? There's a competition I'm trying to join and I would like to advise from you. All right, so there are quite a few example and use cases. Just if you search for this on Google, I think you'll get lots of them. And yeah, all right. Also take a look at our YouTube channel. In past, when we talk about our big data sessions, in big data session, we cover the healthcare and medical challenges, right? The one that are taken care by the computing. All right, so please take a look at the YouTube channel as well as take a look at search on the Google, and you will get a really great answer. All right, so Robert, you had raised the hand. I wanted to know. Yeah, go ahead. You can type the answer. I think I missed your question. Yes, Durgesh, you have raised the hand. And I'm not sure if I may allow you to talk here, but okay. All right, go ahead, Robert. I've made it, I've allowed you to talk. You can unmute and.
You hear me?
Yes, go ahead, Robert.
I want to ask you about the lab itself. I tried to access the lab and I wasn't able to access it.
Okay.
Do I need to re-sign up for that?
No, you don't need to resign. I'll take a look at your account just after the session, or one of my teammates will take a look at it.
Thank you.
All right. Okay. All right. So great. Wonderful to have all of you in the session. There's one last question. How can I start implementing existing frameworks like UNet to solve an image segmentation problem? Let's catch up on our discussion forum. We have a very active discussion forum, and there we talk about, we answer your questions. All right. So we'll be sharing the link to the PPT, and that will be okay, shared with all of you. So thank you again. Thank you all of you to have for your wonderful set of questions. And again, it's amazing to see more than 100 participants staying for 3 hours. 3 hours is a huge time, and I'm really, really happy that okay, I'm really happy that you have stayed back and asked so many questions. I look forward to see you on our discussion forum, as well as see your questions as we go ahead. So feel free to reach out to us at CloudX Lab. Reach us at CloudX Lab. Okay, so I look forward to see you at discussion forum, discuss.cloudxlab.com, and drop me an email at reachus@cloudxlab.com. All right. I'm really amazed by your questions. I really found your questions very, very insightful. And I know that 3 hours is a short time to answer your questions. Feel free to ask questions on our discussion forum, and I, along with my team, would love to answer your questions. There are lots of other learners who basically keep on answering the questions as well as ask questions there. So come over to the discussion forum, as well as reach out to us at reachus@CloudX Lab. Also, the upcoming session on the deep learning is The second one, from second one onwards, it is paid. So you will have to enroll on CloudX Lab, and you'll be having these other chapters. All right. It's a very hands-on deep dive course into the deep learning. Today's session was the most theoretical of all our sessions. All right, Mohammed. Yeah, please reach out to us either on the forum or the email. Okay. Our question is, can I start? Okay, so you can ask it on the forum. Okay, I would love to answer. The next session is going to be on the coming Saturday with respect to India time. And in the US, it is going to be probably Friday evening. So Saturday morning at the same time will be the next session. I look forward to see you. I look forward to see you in the next Saturday's session. Thank you, everyone. Wonderful set of questions, and keep the questions coming. I hope I was able to answer your questions. And thank you again. Bye-bye. Have a great day.